All right, let's start spicing things up with some parametric equations. Now, our parametric equations, we just want to scratch the surface of parametric equations. You're going to do a whole lot more with that in Calc 3. So this section is parametric equations. The next one's polar coordinates. I'm really trying to give you some very tiny basics introduction. All right. And then Calc 3, you're going to be dealing with these a whole lot more. So this is talking about this extra parameter, this extra element that we're putting into these. So in general, parametric equations have that extra parameter t. And T typically stands for time. So what we're really doing is we're still going to be looking at these different equations. However, we have this extra parameter. And the other thing with parametric equations is they're split up. So for example, I have x is equal to f of t and y is equal to g of t, because it's a different function. Still a function, just it's good to denote it by a different variable. So that's what we're talking about. So parametric equations, how do I want to say that? Your x is in terms of t and your y is also in terms of t. So it's two separate things in terms of t. You're adding this additional element, this third element to it, instead of just having these equations just in terms of x and y. All right, so parametric equations, they're buddy equations. You have an x and a y, but they're both in relationship to t. And typically, t represents some kind of time that we're looking at. All right, let me show you an example and see if this helps out. So, here's our first one. I have x is equal to cosine t and y is equal to sine t. And when you have these parametric equations, you have to define t. What am I talking about in terms of t here? And t is going to go between 0 and 2 pi. All right. So t is going between 0 and 2 pi, so I know that that's my parameter. I was trying to think of a different word, but that's really the word. So that's my parameter that we're using here, between 0 and 2 pi. All right? Okay, so let's do this thing. When you have these parameters, we are going to make that chart. So we have t we're looking at, we have x we're looking at, and we have y we're looking at. I got a little overzealous there. So when you have t, you're setting up your t. I know t is going between 0 and 2 pi, so let's hit some highlights that go with that. So I'm going to know when t is 0. And then if we break up this 2 pi, we're going to break it into things that are easy to work with. So I'm going to look here at pi over 2, pi, 3 pi's over 2, and 2 pi. All right. So I'm going to say, all right, what is the point that goes with these? So if I have when t is equal to 0, I'm going to take 0 and plug it in for my t. So I'm going to write this out just so that we have it, but I'm not going to write it out for everything, right? So x is equal to the cosine of 0. Well, what is the cosine of 0? 1. Good. And I'm also going to say y is equal to the sine of 0. What's a sine of 0? 0. And then you do that. So x is equal to the cosine of pi over 2. That one is 0. Y is equal to the sine of pi over 2. And there we get 1. Do them for everything. Cosine pi, sine pi. The cosine of pi is -1 and the sine is 0. The cosine of 3 pi over 2 and the sine of 3 pi over 2. So the cosine is 0 and the sine is -1. And cosine of 2 pi and the sine of 2 pi. 1 and 0. All right? So when we go to graph this, so I'm going to put it over here on a graph. We are going to be doing some graphing today. I'm going to put it out here. This is a 1. This is a 1. Negative 1. Negative 1. Just so that I have it nice and set up. Then I'm going to do my graphing. Now, here's the other thing whenever I'm talking about parameter. Parameter has direction and movement. All right, that's the whole point here whenever I'm going to sketch this graph. So we want to sketch the graph. I'm going to go red just so we can see it. So I have the point 1, 0. And then I have the point 0, 1. I have the point negative 1, 0. 0, negative 1. And then back here to 1, 0. All right. So, hey, not too shabby, right? Now, here's the real deal whenever it comes to parameters, all right? So this is a circle. This is a circle no matter what, it's a circle. But this is the parameter part of this. My first point here at 0, I'm going from 0 to 2 pi. So my first point here at 0 is where we are going to start. Then I am moving up here to the point 0, 1. Then I'm moving over here to negative 1, 0. Then down and then back up again. When you have a parameter, it's called orientation. It's your movement as you go through. So you put those movement on there. And then you're stating where you start. All right, so it is a circle, yes. However, this specific circle from 0 to 2 pi, because of how this parameter is designed, I'm starting here and then I'm going counterclockwise. Kind of like the unit circle, right? So I'm moving around in that counterclockwise fashion. Okay. Let's do it. Let's do another one. What if I change this up a little bit? And I say x is sine of t and y is cosine. Still going to go between 0 and 2 pi. Let's see how this affects our graph. So same thing, let's set up the chart here. I have my x and I have my y. And so t is going to be 0, pi over 2, pi, 3 pi's over 2, and 2 pi. So if I plug in a 0, x is equal to sine of 0, and y is equal to cosine of 0. So x is now 0. Let's change it up a little. And y is 1. You see that? Okay, do the rest of them. I'm not going to write all these out again because you can just do this, right? If I plug in pi over 2 to sine of pi over 2 here is 1, and the cosine of pi over 2 is 0. Pi of sine of pi is 0. Cosine's negative 1. 3 pi over 2 is negative 1. Cosine is 0. And then back to that 2 pi to get that. So let's see what our graph looks like here. Same setup. All right. So my first point on this is here at 0, 1. So 0, 1. Look what just happened. Right? Now I am starting up there at the top. Then my next point is 1, 0. What? What else just happened? Now we're going in the other direction, right? 0, negative 1, negative 1, 0, and back to 0, 1. only thing that changed here was the fact that I swapped out my X and my Y. Not only did my starting point change, but my direction also changed. And that's the deal with these parametric equations. All right? So that's that extra element. It's saying, okay, where am I starting and how am I moving? That's going to be the change set up here with these parametric. All right? And they stop. They start and they stop. So this is just not swinging around in the circle endlessly. It starts and it stops. So it starts here, comes around, and then stops. It doesn't go any farther. You don't just keep running around and around because you start and stop. That's what the point of that parameter is. It just tells you where you're going from. All right? Okay, let's do another one here. So that's sine and cosine, which is nice. Let's look at this example 1. Graph the parametric equations. All right. X is equal to 2t. Y is equal to a 1/2 t squared minus 4. And 0, which is less than or equal to t, which is less than or equal to 8. All right. So for my parameter, I know that we are going to start at 0 and stop at 8. And then the same thing is being set up here. So you can do a few points along the way. I'm going to do a whole bunch of points just because I want you to see what it looks like. So if I'm t, we're still making the chart. This is just how this works. And you've got your x that goes with t and your y. So your x and y are what you actually graph on your coordinate system, but your t tells you what that's going to be. So I'm starting at 0, so I have to have the 0, but I'm going to do everything. 1, 2, 3, 4, 5, 6, 7, 8. So now I know here x is equal to 2 times 0. Well, that is 0. And I'm just going to go down through my x's. X is equal to 2 times 1, so that's 2. 2 times 2, I'm not going to keep writing all these. 2, you plug that in. 2 times 2 here is going to give me 4, 6, 8, 10, 12, 14, 16, right? I mean, you can see how that progresses. Now, if I have y is equal to a 1/2 times 0 squared minus 4, so y is equal to a negative 4. Y is equal to 1/2 times 2 squared minus 4. I'm sorry, 1. I'm plugging in t. Plugging in t. I looked at the x. We're not plugging in x, we're plugging in t. So now this is 1/2 minus 4 is going to give me, and I'm just going to put this in terms of mixed numbers because we're graphing instead of improper fractions. So 1/2 times 4 is negative 3.5. That way I can graph it better since we have to end up graphing it. Then I plug in y is equal to 1/2 times 2 squared. So I know if it's even, it makes it nice because this 2 goes into this, just giving me 2 minus 4 is a negative 2. Y is equal to 1/2 times 3 squared minus 4. So this is 9/2. So 9/2 is the same thing as 4.5. So 4.5 minus 4. That's going to be 1/2. Y is equal to 1/2 times 4 squared minus 4. So that is 16 divided by 2 is 8. 8 minus 4 is 4, right? Then do 5. Y is equal to 1/2 times 5 squared minus 4. So 25 halves is what? 12.5? So 12.5 minus 4 is going to give me 8.5. Okay. 1/2 times 6 squared minus 4. So 6 squared is 36 divided by 2 is 18 minus 4. So the evens are nice because they work themselves out. 1/2 times 7 squared minus 4. So 7 squared is 49 divided by 2. What would that be? 24.5? Would be 20.5. Okay. Lastly, y is equal to 1/2 times 8 squared minus 4. So 64 divided by 2 is 32 minus 4. 32 minus 4 is going to give me a 28. Okay. And when you do this, you want to do your points first, right? You want to get all your points set up and ready to go, because now whenever you go to make your coordinate grid, I know that x's starting here at 0, so I don't really need to go to the left of my axis at all. But my y's go from -4 up to 28. So then we have to set those up. So, oh, that's horrendous. You got a grid to follow. Oh my goodness, that is not much better. One more try. Yeah, that's a little better, isn't it? Okay, so I'm going to go in terms of 2's on the x-axis. 2, 4, 6, 8, 10, 12, 14, 16, because I want to go up to 16. All right. 2, 4, 6, 8, 10, 12, 14, 16. Then I know I've got to go down from -4 up to 28. I think I'm going to go by 4s on that because I got to go all the way to 28. So this will be 4. So this down here is going to be -4. And that would be 4, 8, 12, 16, 20, 24, 28. All right, just so that I have that. Okay, now let's put our point on there. So I have the point 0, -4. Then I have the point 2, -3.5. So it's really close to that. Then I have the point 4, -2. Then I have the point 6, 1/2. Then I have the point 8, 4. I have the point 10, 8.5. So just barely above that. And then I have the point 12, 14. So 14's halfway between there. Then I have the point, 14, 20.5. And 16, 28, right? Now, here's the kicker. When you have this, so you can see that my graph is moving in this direction, right? Because that's the points that we came up with. That's the progression that we're looking at. My graph starts at 0 and it stops at 8. So I am starting at 0. I'm going to make this bigger just so I can graph it a little bit better. Starting at 0, moving up, and stopping. Then you also have to put orientation on there. So a positive orientation is how the graph moves. We should have written that up above, but I forgot. Positive orientation is how the parameter increases. All right. This parameter happens, oh, for crying out loud. This parameter happens to be going from down to up. They don't always do that. So positive orientation, if this had started over here and gone like this, that would have also been positive orientation, because it's however your parameter increases. Whatever these values are, that is what we're talking about. That's how the parameter increases. This is always going to be from small to big, but sometimes these values are going to change it to be going in a different direction. Such as, what if this had been like a negative 2t, right? I would have started over here and then worked my way. That would have made a difference. Okay, this would have all just made a difference. That would have been negative, whatever. But if you would have started here and then worked your way down, that's still considered positive orientation, because positive orientation is just where your parameter increases. Where you start to where you stop. Notice, do I have any arrows at the end of this? No. If you try to put arrows in there, you're going to be wrong. You start and you stop. Okay, that's a big deal when it comes to parametric equations. It's not some infinite domain. You have a starting and a stopping point.